The standard error of the mean is this quick little formula. It's the old standard deviation divided by the square root of the sample size. So for this problem, they tell us the standard deviation is 2.5 and the sample size, they had 36 fill up, so 36 for a sample size. So, this one's nice and easy because the square root of 36 is just 6. And then with our calculator, we can do 2.5 divided by 6. So the standard error to 4 decimal places, 0.4167. Within what interval would you expect the sample mean to fall with 99% probability? So this is like an earlier question we had in our homework. To calculate a 99% confidence interval, that means you're going to have 0.5% in the tails. So the z-score in a table in the back of a textbook, or a z-score we look up in a calculator, should be 0.995 because of that extra 0.5 in the tail. Because what the tables tell you is the area to the left. Tables usually don't have two-tailed confidence. So I'm going to type in percentile to z-score calculator. Let's check out the first one. That looks good. So we're going to type in 0.995 like we said. That's the z-score that gives us 99% in the center. Okay, so sorry, the reason why we need that, I just realized you might be watching this video and you might not know why. It's because in a previous video we said that to calculate a mean, if you have a population mean and a population standard deviation, which they told us a population mean, the confidence interval for that mean is that mean plus or minus a z-score that corresponds to whatever confidence level you have times the standard error, which we actually just calculated up above. So they gave us the mean was 26.75. I plugged that in for mu. Got the plus or minus symbol. I looked up the z-score with an online calculator. And then the standard error I got in part 1 was 0.4167. Okay, so to calculate 2.5758 times 0.1, can multiply those two. That's the margin of error for our confidence interval. We got 1.07333. That's probably enough right there. And so to calculate your interval, you do this once for plus and once for minus. So I'm going to take 26.75 and subtract the margin of error. And I think they also ask us to round this to 4 decimal places, so this one rounds up. That's the lower end, the lower bound of the interval, we call it. And then we do it once for plus. So to 4 decimal places, that's the upper bound. So those are the two numbers you need for your interval. And what that means is we're 99% confident the true population mean is somewhere between these two.